letter. He's the yeah, it's not my question. I'm sorry. Okay.
So we're just going to go through some of these examples. Make sure you're paying attention, writing this down. We are going to be solving absolute value equations. This is going to be very similar to solving regular equations, except with a slight twist. Which on your papers over here. So the steps to solve this, we first have to make sure the absolute value expression is isolated. So it has to be by itself. There can't be anything connected to it, touching it, adding or subtracting from it. After it's isolated, we're going to set the inside of the absolute value bars are equal to a positive and negative version of whatever it equals. We'll see what that means in a second.
Oh, I'm leaving early. What is this? Counseling. I'm going to cry, Miss Gordon. What do you need counseling for? Should I go now?
I just was handed a pass. It says unavailable, so yeah. No.
I can take it.
No. Okay. Number 3, solve both equations.
Can I take everything or?
I don't think you need everything.
Okay.
I think you'll come back.
I do it.
Okay. Take the pass.
Yeah, that'd be useful.
And then after you solve, you're going to write your answer as a solution set. Guys, to make sure you're writing this down. So then if you're writing this down. You're writing this down. So if we had example 1, this is already isolated, so we don't have to do anything. The only thing on the inside is x, so we're going to set this equal to a positive and negative version of 2, and we're going to write it as one condensed equation. Negative 2 equals x equals 2. If there were anything left in here to solve, we would solve, but in this case it's not, it's just x. So then we can write this as a solution set. X equals negative 2 and 2. Do we have any questions on that one? For number 4, we would do the same thing. This is already isolated. So we would take that inside, set it equal to a negative and positive version of 28. So negative 28 equals negative 7a equals positive 28. Then you could solve both of these, or all of these, by dividing everything by negative 7. So we now have positive 4, a, and negative 7, negative 4, not 7. And then our solutions would be negative 4 and 4. Do we have any questions on that one? For number 7, same thing. This is already isolated, so we're just going to set what's inside equal to a positive and negative 34. Notice that when we do that, we're dropping the absolute value signs. We no longer need that. And then we can solve. So get rid of the 2 by subtracting everything. Negative 36 equals 4n equals 32. And then divide everything by 4. Negative 9 equals n equals 8. And then our solutions would be n equals negative 9 and 8. Do we have any questions on that one? We're just going to do a few more of these and then we'll switch gears and go back to final exam review. On the back, if there's stuff outside of the absolute value bars, we need to isolate the absolute value bars. Get them by itself. And we're going to do number 12. So in this case, we have a negative 2 outside the absolute value bars. We would need to get rid of that by dividing, because right now these are multiplying since they're next to each other. If we divide both sides by negative 2, we have the absolute value of z plus 3, and now equals positive 7. And then once our absolute value bars are isolated, we can set this equal to a positive and negative version of this number. So negative 7 equals z plus 3, which also equals 7. And then solve for z by subtracting 3 to everything. So negative 10 equals z equals 4. So z equals negative 10 and 4. Any questions so far? For 14, same thing. Just like in a regular equation, you would get rid of whatever is adding or subtracting first. You're also going to do the same thing here. Get rid of this 3 by adding it to the other side.
You want to say that?
Then divide both sides by negative 10. And then set it equal to a negative and positive version of 8. And solve for h by subtracting each by 5. I'm writing this over here because I'm writing answers. So h equals negative 13 and 3. Questions on that one? One last thing we need to talk about with this. If we have absolute value bars that are already isolated, and it equals a negative, like from the beginning, we haven't done anything and it already equals a negative. We can't solve this at all. No way possible to solve it. This would be no solution. Now, if it starts off with a negative, but there are things around the absolute value or things inside, we can't assume, scratch the last part, just things around it. So like, if I go back, this started off as a negative, but once we isolated it, that negative went away, so we were able to keep solving it. Had that stayed a negative, that would have been no solution. There are also sometimes we won't know if it's negative or not until we start isolating it. So here, if we divided both sides by -3, then we end up with a negative, and that would tell us this is no solution, we can't solve this. Do we have any questions on this? So we are going to now switch gears and continue working on the final exam review. We should be able to finish the final exam review today. If we don't, then we'll finish part of it next class. For next class also, we're going to be doing the last piece of this, which is absolute value inequalities. Or we may touch on that today and then not do it tomorrow, or next class. So if you are taking the final exam review, make sure you have that out. If you need extras, there are some on the shelf back here.
I'm definitely gonna not pass it. I'm mentally already in summer. My brain is shut down.
We got through 7.3 and we're going to start at 7.4. Grab your calculator if you don't already have it. This formula wasn't on your final exam review sheet, but it will be on the test. So this is not something you need to memorize, but just so you have it for now. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Write that down.
Wait, last time I was here, we did 7.1, 7.2, and 7.3.
I feel like we did more than that, but yes.
When I was in, it was one day in the store.
There's a lot that we have to get through.
Are you being serious?
You can look at the class recording to see what all we did, but I feel like we did a lot.
Like I was what?
I feel like we did a lot. Okay. So for all of these problems, you need to be able to list out or label what your A, B, and C values are. So for this, our A value is the one in front of the square term. We don't have a B term, so off to the side we say B equals 0. And our C term would be -36. Then we're going to take these variables or coefficients and put them into this formula. -b would be -0, so just 0 is fine. Plus or minus the square root of b squared is 0, so that would just be 0. minus 4 times A, which is 1, times C, which is negative 36, all over 2 times A, which is 1. So put all of your numbers in as your first step. Then you could start to simplify in your calculator. If you put this inside in the calculator without the square root, 0 minus 4 times 1 times negative 36, it will simplify it for you. And then if you're not sure well, first write this as you're jumping ahead. So x equals 0 plus or minus the square root of 144 all over 2. If you know that this is a perfect square, you can go ahead and take that. If you're not sure, or maybe you don't remember all the perfect squares, you can do that in your calculator. Second, x squared will give you your square root, and that would give you 12. So x equals 0 plus or minus 12 over 2. Then you're going to separate this into 2 different fractions. X equals 0 minus 12 over 2 and 0 plus 12 over 2. Negative 12, or 0 minus 12 would be negative 12, divided by 2 would be negative 6. 0 plus 12 would be 12, over 2 is positive 6. So our answers, or our solutions, would be negative 6 and 6. Do we have any questions on that one? Moving on to the next one, same thing, label your A, B, and C values. Then we can put each of these into the format negative b, so negative 5, x equals negative 5, plus or minus the square root of b squared would be 25, minus 4 times a, which is negative 6, times c, which is 91, all over 2 times a, which is negative 6. Again, we can put this inside in the calculator and see what that is. 25 minus 4 times negative 6 times negative, or positive 91. So 2,209. We can write that as a simplified version, negative 5 plus or minus the square root of 2209 over negative 12. I don't know, I wouldn't know if 2,209 is a perfect square or not unless I tested it. So here, if I put this in, I got a whole number. If I didn't get a whole number, then I would just leave it as the square root of 2,209. So then we can separate it into our 2 fractions and then simplify and find our answers. So we have negative 5 minus 47 over negative 12 and negative 5 plus 47 over negative 12. -5 minus 47 would be -52. And I can put that in my calculator. Alpha y equals would give me my fraction. -52 over -12 would give me 13 over 3. -5 plus 47 would give us 42. And 42 over -12. It should be positive 42. Would give us positive 7 over 2. Negative 7 over 2. I would have thought this deleted, but it's not. There we go. And those would be our two solutions. Do we have any questions on quadratic formula? Caleb?
You put the ABC formula in the calculator.
You mean altogether?
Yeah.
If you put all of these numbers in here, you could get decimals you don't want. So, no. Simplify each step. Are there any others on this page we want to see or go over?
Mr. I'm sorry, real quick. You said this is going to be on the final exam too? Oh, I'm going to cry.
So on to the next page. We are now in Unit 8. For 213, it's asking about domain and range. Remember that domain is your x values, looking at all of your x values, left to right. When you do that, you have to imagine that this keeps going off the graph, off the page, forever and ever in both directions, left and right. Because it keeps doing that, there isn't a exact starting or ending point. It just keeps going to negative and positive infinity. So that's what our domain is going to be, negative infinity to positive infinity. Our range, we're looking at lowest to highest. So lowest, this is going to keep going off the graph, off the page, starting at some negative infinity. But this does have a stopping point. It stops at 2. And because this isn't an open circle, this would be a bracket. Do we have any questions on that one? For 215, this is asking for you to look at your x values left to right. For increasing, it's where your x values keep moving forward, but your y values also go up. So from here to here, your x values are moving forward and your y values are going up. Both of those end at or have closed circles. So these would both be brackets starting at 0, going to 2. Decreasing, same thing when your x's are moving forward, but now your y values are going down. And here it does that, but it starts somewhere out here. So left to right, this starts decreasing somewhere at negative infinity. And it ends at 0. And then for constant, you're looking for somewhere where your x's keep moving forward, but your y's stay the same. So this would start at 2 and end at 7, but 7 is not included because it has an open circle. So that would be a parenthesis. With each of these, you should be able to start at some place, wherever it stops, pick up at another place, and then wherever that stops, pick up at somewhere else. Do we have any questions on that one? For 217, we are writing this in interval notation. So basically kind of what we've already been doing, writing these were interval notations. So we want it to look like something like this. This starts at -3 and it ends at 0, where -3 is not included, but 0 is. So this would start off with a parenthesis and end with a bracket. Questions on that one? And then for our last one, 222, ignore the actual word infinity, it's supposed to be an infinity symbol. But we need to write this so that it's in set builder notation, so it's going to look like one of these. It starts at -4 and it goes to infinity, so it's going to be everything above -4, or greater than or equal to -4, because this is a bracket. So we know this much, and then we just need to make it look like this to make sure the line behind it, the x is behind it, and you have the curly brackets. Are there any others on this page we want to see or go over? On the next page, 8.2, you are writing equations from transformation descriptions. So starting at 225, we have this function, our quadratic. It's translated 5 units up. Up is a vertical thing. Anything vertical is outside. Or will be outside. And if this was outside, we would do exactly what it says, and this would be +5. Reflected across the y-axis, if this is my y-axis, it's going like this around it. This is a horizontal transformation, so that has to be inside. And that means there's going to be a negative on the inside. So now that we have that for both of these, we can write our equation, starting with f of x equals, this outside is going to go with the back. So we can go ahead and put our inside piece, -x in parentheses. This is a squared function, so we need that. And then +5 on the outside. And that would be our function. Questions on that one? And then we're going to do the last one. Now we have absolute value function. It is compressed vertically by a scale of 1/2. Vertically, this tells you this is outside. The scale tells you what you're multiplying by. So So we're going to be multiplying by 1/2. Reflected across the x-axis, if this is my x-axis, it's going like this. So that would be a vertical transformation, so that is also outside. So somewhere on the outside we would have a negative. And then translate it 12 units to the left. Left is a horizontal transformation, so that is inside. But inside things don't do what you expect them to. So if you were thinking, well, I'm moving to the left, so that has to be a negative, it's really negative, negative. So this is going to be a plus 12 on the inside. So putting all of those pieces together, our function would be f of x equals this negative on the outside, and this scale would need to come first, so negative 1/2. And then on the inside, we have our x plus 12, but because this is absolute values, you don't need parentheses. And that would be our equation. Questions on that one? Or any other questions on this page? On the next page, we are now writing equations from graphs. So a couple things. We need to figure out what transformations happen. We need to know what function this is. And then put all those things together. So this should be a quadratic. If we were to draw in our original, that original quadratic starts at 0, 0, goes up 1 to the right 2, up 1 to the left. I'm sorry, I said 2. I meant 1. I think it's whoever's phone is on the thing. I don't think it's that one. I think it's the one behind it.
That's crazy. I know.
And then go out to the right 2 and up 4, and out to the left 2 and up 4. That would be your original parent function. So if we're comparing this parent function to what's drawn, we can see it was flipped. If we're comparing the vertex, this vertex has been moved to the left. 1 and up 8. And then we also have to look at our scale to see if that's been changed. So normally we go up 1, left 1, or up 1, right 1. This is going from the vertex down 2 into the right 1 and left 1. So our scale is now 2 instead of 1. So if we put all those things together, start off with our function f of x. Negative and scale needs to go in the front because these are both outside things. Negative would go first, and then our scale. Left is on the inside, so we would do that next. In parentheses, this would be a plus 1. But our function is squared, so we need to remember that. And then the last piece would be our up 8 on the outside. Negative 2 in parentheses, x plus 1 squared plus 8 would be our equation. Yes. I was just confused how you know how to. So you have to know your transformations. You have to know from here to here, where did I move, what directions did I go, and know how or where these things go. For 235, same thing, except this is not an absolute value function. Our original parent function would start at 0, 0, go up 1, right 1 as many times as possible, and then up 1, left 1 as many times as possible. And if we're comparing that original to the one that's given, I know it didn't flip because they're both facing the same way. This vertex has been moved to the right 3 and down 2. And then I have to look at the scale and see, is the scale the same? Am I still going up 1 to the right 1? But in this case, I'm going up 1 and to the right 2, and up 1 to the left 2. So the scale is now 1/2 instead of 1. The scale and the down would be outside things. The right would be an inside thing. The scale would come first after we write our f of x. So f of x equals 1/2. Then our inside piece, it would be opposite of what you think, so -3. And then outside of that, -2. Questions on that one? Next objective. 8.4, we are now describing the transformations, so just putting them into words. We do need to be specific, use words like translate if it moved, up, down, left, right. Reflect if it's been flipped, and then over which axis. And then if there is a different number out here other than 1, figure out the scale factor. So for this first one, this negative would be a reflection. It's on the outside, so that would be a vertical reflection, which means it has to reflect over the x-axis. And then the 1/2 would be a scale, vertical scale, by or vertical compression by a scale of 1/2. And then the -3 on the inside, we're going to translate to the right 3. Questions on that one? And then for 239, we only have two transformations, the negative and the +2. The negative would be a reflection. But because it's on the inside, that would be over the y-axis. The +2 on the outside would be a translate up to. Questions on that?
You got the right word.
Yes. You have to describe the transformation. Okay. 8.5 is on that same page, but further down. So where you are graphing absolute value and quadratic functions. So here I'm going to show it to you without using the calculator and then in the calculator. This first one, do we need to find your vertex? Look for anything in here and numbers out here. So if you don't have a number inside, you can assume that's 0. And the numbers on the outside would be -1. So we have the point 0, -1 to start. And then our scale is 2. So instead of going up 1, right 1, we're going to go up 2 to the right 1 and keep doing that at least 5 times. And then do it the other way as well. Go up 1 or up 2, left 1 and keep doing that as many times as possible until you have at least 5 points. In your calculator, you could put this in. So if I go into y equals and I type in 2 absolute value alpha window x and then -1, and then I go into my table, I could find my vertex at 0, -1, and I could find other points and graph those onto my graph. Questions on that one? .245 is similar. The vertex would be this and this, except whatever's on the inside, make the opposite. So we would start at -1, 3. Double check and see if the scale changes or if there's any flips. If not, then this would be graphed just like the parent function. Go up 1, right 1, up 1, left 1, then out to the right 2 and up 4, and out to the left 2 and up 4. You could also check that in your calculator. So if I go in and type in x minus 1 or x plus 1 plus 3 and go into my table, look for my vertex of -1, 3 or -1, 3, and then I could plot those points. Do we have any questions on that one? There are others in the section, but they're on the next page. Are there any of those we want to see or go over? we're gonna do one more section today. We'll leave the last section for when we go over the inequality stuff. So 10.1, solving absolute value equations. Find that. We're just gonna do a couple of these and then be done for today. For 254, we again have to isolate this. So we have to get rid of this 8 by multiplying it to the other side. If we multiply it to the other side, now it's isolated, but this equals a negative from the start, which means this has no solution. We cannot solve this. For 255, we would start solving this, get rid of 9 by subtracting it. Divide both sides by 10. And now that it's isolated and it equals a positive, we can set it equal to a positive and negative version of 4. So negative 4 equals x minus 7, which equals 4. Add 7 to both sides, to all sides. So 3 equals x, which equals 11. And those would be our solutions, 3 and 11. Do we have any questions on that? Okay. So, a couple things. Next class, we're going to go over how to do absolute value inequalities, and then do a couple problems on the last page of this. For the rest of class today, and after we finish those next class, you'll have time to finish making up tests, do retake work if you so choose. Remember that if you're taking the final and you do well on the Unit 8 and Unit 9 stuff, that will automatically replace that. You don't have to retake. You still can. You still have that choice. But it will go back and replace those. So, as for the rest of class, if you are missing a test, I'm going to come around so you can start that. If you need to retake a test, you'll need to come to me to come grab your test and all of those things. Rashad, come here for 1 second.